Often, we need to execute a sequence of operations where each operation can fail. For example, if we have a value a, we might execute an operation that takes a and returns an either e1 or b. Then, if that was successful and we have a value b, we might execute another operation that takes b and returns an either e2 or c, and so on. Let's see a concrete example of how we can do these sequential operations that can fail using the iter type and the utils that FPTS provides. Let's say that we want to define a function, decodeUser, which decodes an encoded user object. To understand how to perform the decoding, let's see how the user object is actually encoded. So we start with a user object that has an ID and a username. For example, we could have a user with ID 1 and username Jamie. We then JSON stringify it and finally encode it as base64. So our decodeUser function should take the encoded user, which is a base64 string, and decode it to a user object. So the first thing we want to do is to base64 decode the received string. We can write a base64 decode function that decodes a base64 string into a UTF-8 string. Since the decoding can fail in case of invalid base64 strings, we want to define a custom base64 decode error. Then, to do the actual decoding, we will use the base64 npm module instead of using the native Node.js buffer so that we get an error for invalid base64 strings. So we start by importing base64. The base64 module has a decode function that throws an error in case of an invalid base64 input. So we can convert it to a function that returns an iter using iter try-catch k. So we now have a function that takes an input string and returns either base64 decode error or string. Returning back to the decodeUser function, the first thing we want to do is to base64 decode the encoded user. So we could pipe the encoded user into base64 decode. The result that we get back is an either base64 decode error or string. Next, we map the base64 decoded string into our custom JSON parse function. Remember that our JSON parse function takes a string and returns either JSON parse error or unknown. So after mapping, we get back either base64 decode error or either JSON parse error or unknown, which is a nested iter. Working with a nested iter is not ideal, so we should flatten it. Similar to how we can flatten nested options, we can flatten a nested iter using iter flatten. However, notice that we get an error. Type JSON parse error is not assignable to type base64 decode error. This is because flatten expects that the error types of the nested iter are the same, which is not the case in our example. Instead, we want to use flatten W, where the W stands for widening to indicate that we're widening the error type, that is, making it a union of the errors. So now we have an either base64 decode error or JSON parse error in the left case and unknown in the right case. These two operations, map and flatten W, are so common that there is another util that does just that. It's called iter flatMap. So we can replace the map and flatten W with just flatMap. Finally, we should decode the unknown value that we got from JSON parse into a user object. That is, we should verify that it's actually an object with the correct properties. Let's assume that we have a decodeUser object from unknown function that ensures that the received unknown value represents a valid user object. So it takes unknown and returns either invalid user object or user. I'm not going to go over the details as it's out of scope for this video, but this kind of validation can be done using a schema validation library like IOTS. So going back to the decodeUser function, we can map the parsed JSON into decodeUser object from unknown. However, we again get a nested iter. So we actually want to flatten the iter after mapping, which we can do by using flatMap. So the final output is either base64 decode error or JSON parse error or invalid user object in the left case and a user object in the right case. To get a better understanding of how this works, let's see what actually happens step by step when we call decodeUser with a valid input. First, we pipe encoded user, which is this base64 string, into base64 decode. Since this is valid base64 that encodes a JSON string, we get back a write with that JSON string. Then we flatmap that JSON string into JSON parse and get back a write with the corresponding object. Finally, we flatmap that object into the decodeUser object from unknown, which successfully validates the object and returns a write with that object, and this is the final output that our function returns. Let's also see what happens when we call decodeUser with a base64 string that encodes an invalid object. So we pipe encodedUser into base64 decode. Since this is valid base64 that encodes a JSON string, we get back a write with that JSON string. Then we flatmap that JSON string into JSON parse and get back a write with the corresponding object. Finally, we flatmap that object into the decodeUser object from unknown, and since the object fails validation, we get back a left with an invalid user object error. And this is the final output. Next, let's see what happens when we call decodeUser with a base64 that encodes an invalid JSON string. Again, we pipe encodedUser into base64 decode. Since this is valid base64 that encodes invalid JSON, we get back a write with that invalid JSON. We then flatmap that invalid JSON into JSON parse and get back a left with a JSON parse error. Finally, when we attempt to flatmap that left, we get back that same left since there is no value to map. Lastly, let's see what happens when we call decodeUser with an invalid base64 string. So we pipe encodedUser into base64 decode. Since it's invalid base64, we get back a left with a base64 decode error. Then, when we attempt to flatmap that left, we get back the same left since there is no value to map. The same happens when we try to flatmap that left again. So the final output is a left with a base64 decode error. It's important to note that either flatmap was introduced in FPTS version 2.14.0. In prior versions, the equivalent functions were chain and chainW, which, by the way, are still available in v2 but considered legacy. Chain is the combination of map and flatten, while chainW is the combination of map and flatten W. So flatmap is the new name for chainW, while there's no new equivalent for chain. That shouldn't be a problem because it's not common to want to enforce that a nested iter has errors of the same type. It should be fine to let the error type widen when dealing with different errors.